discuss about Regula Falsi method. So, as we discussed in a previous lecture, Regula Falsi method is also a bracketing method. Means there is a need to find out a value where the value of the function is a positive, another value where the value of the function is negative. So, suppose graphically how we describe the Regula Falsi method. Suppose this one is a y equal fx, y equal fx, y equal fx, y equal fx. Here we try to describe the Regula Falsi method. Regula Falsi method. Regula Falsi method. And Regula Falsi method is also known as the what? False position method. False position method. False position method. False position method. So, as we know that Regula Falsi method or false position method is also a what? Also a bracketing method. So here we try to find out a point where the value of the function is a negative. Suppose this point is a and the coordinate of this point is a f of a. Coordinate of this one. And one value where the value of the function is positive. Suppose this one is a b, and the coordinate of this point is a what? b f of b. b f of b. Now, what will happen in a Regula Falsi method? In a bisectional method, we find average of these 2 points a plus b by 2, midpoint of this class interval. But in Regula Falsi method, we draw a straight line between these 2 points. We draw a straight line between these 2 points. Then find the equation of this straight line. Then point of an intersection with x-axis. This one is a what? This one is a nothing else. First approximate value. Suppose this one is a what? This one is a x0. This one is a first approximate value. Now we find point of an intersection with value of the function, not a point of intersection, value of the function at this point. The value of the function at this point is a what? x0 f of x0. Now we draw the straight line from this point, because at this point the value of the function is negative, at this point the value of the function is positive. So this one is a necessary condition, means in any bracketing method, one point where the value of the function is negative, another point where the value of the function is positive. Now here we again draw a straight line between one positive point and one negative point. Again find a point of intersection with x-axis. Suppose this one is x1. Then find the value of a function at this point. The value of a function at this point is the what? x1 f of x1. Now again, at this point, the value of the function is negative, because this one is in this quadrant, fourth quadrant. In a first quadrant, the value of the function is a positive. Again, we draw the straight line and find the values, next approximate value. Suppose this one is a what? x2. So, what we observe, this one is a what? This one is our actual root. Suppose this one is alpha. First approximate value is x0, second approximate value is x1, next approximate value is x2. slowly we approach to our actual root. So this one is a x0, this one is a x2, this one is a x1, this one is a x2. Similarly, x3, x4, x5. Then we approach to our actual root. So after certain iteration, either we able to find out the value of alpha or a point near to the alpha. Near to the alpha. Now, mathematically, how we find the values of x0, x1, x2, x3 and xn. Now, here we draw a straight line between 2 points. So as we know that, what is the equation of a straight line between 2 points? Y minus y1 equal y2 minus y1 divided by x2 minus x1 x minus x1 x minus x1. This one is the equation of a straight line. Straight line between 2 points. Between 2 points. 2 points. And obviously points are x1, y1 and x2, y2. So now here suppose A is the x1 and this one is f of A is a y1, B is a x2 and f of B is a y2. So here we put the value, suppose x1, y1 with the A f of A and x2, y2 with the B f of B. So what is the equation of a straight line? Equation of a straight line is a y minus y1, y1 is the f of A equal y2 means f of B minus f of A divided by B minus A, because B is the what? X2. Now x minus x1. X minus x1, and what is the value of x1 here? Value of x1 is A. Now this one is the equation of a straight line between A f of A, B f of B. Now how we find the point of intersection with x-axis? Obviously we put y equal to, say, y equal 0, because this one is a what? This one is the equation of a x-axis. Equation of a x-axis. So if we put y equal to 0, so this one become what? Minus f of A, f of B minus f of A divided by B minus A, x minus A. If we simplify this one, x minus A equal minus of B minus A, this one multiplied by this one, f of A divided by f of B minus f of A. If we simplify more, so x equal A, this one becoming a positive sign here, A minus B minus A f of A divided by f of B minus f of A. So if we simplify this expression, x become A f of B minus B f of A divided by what? Divided by f of B minus f of A. F of B minus f of A. Now here we denoted the x by what? First approximate value is x0. So here we write what? Here we write, in place of x we write x0, because we assume what? We assume the first approximate value is x0. So x0 is x0 equal, say, AF of B, AF of B will be right here, means not here, it will be right here, x0 equal what? AF of B, AF of B minus BF of A, BF of A divided by F of B minus F of A. This one is a iterative scheme for the Regula Falsi method. One another things that need to concentrate on our Regula Falsi method, need to observe, if we closely observe the geometrical interpretation of our Regula Falsi method, you may see means one end is fixed, means in this case one end is fixed and another end varies, means this one from A f of A to x0 f of x0, x1 f of x1, and this one means a root lie between A f of A, B f of B, and root lie between x0 f of x0 and B f of B, means this end is fixed and only this end varies. So it's not necessary here the positive end is fixed and negative end is varied. Maybe in some situation, means if the graph is like this one, means if graph is like this one, not this one, if graph is like this one, means here, like this one. So what will happen here? Suppose here the value of the function is a positive, here the value of the function is a negative. Negative. So here the value of the function is a positive and here the value of the function is negative. In this case also, this one here, what is the value of this one is a first point of intersection. Suppose this one is x0, this one is a f of A, and this one is a what? B f of B, B f of B. Now point of intersection of a straight line is this one and value of the function is this one. Now again we draw a straight line like this one, and this one is a first, second approximate value x1, and this one is a one another value. Now what we try to say here, in this case positive end is a fixed, but in this case negative end is a fixed. Positive end varies from A f of A to x0 f of x0 and x1 f of x1. So one end is a fixed and another end varies. So it's not necessary only positive end is a fixed. Maybe negative end is fixed. This one depends on the nature of a function. What is the nature of a function? Accordingly, maybe the positive end is a fixed or negative end is a fixed. We try to solve the we try to find out the solution of an algebraic equation with the help of a Regula Falsi method. Now suppose here we consider fx function is a what? Function is a x cube minus 4x, x cube minus 4x plus 1, x cube minus 4x plus 1. Now we try to find out the root correct up to 4 decimal places. Correct up to 4 decimal places. 4 decimal places. 4 decimal places by the Regula Falsi method. Regula Falsi method. By Regula Falsi method. So as we know that this one is also a bracketing method, So first we try to find out the point where the value of the function is a positive, another point where the value of the function is negative. So f of 0, suppose x equals 0. What is the value for function f of 0 equal, this one is a 0 minus 0 plus 1. This one is a what? This one is a positive value. X equal to 1, x equal to 1, then this one is a, this one f of 1 equal 1 minus 4 plus 1, this one equal minus 2, this one is a negative value. So now we stop ourselves because we able to find out a point where the value of the function is a positive, another point where the value of the function is negative. Now suppose here we denote this one is a equals 0 and f of a equal 1 and v equal 1, f of b equal minus 2, f of b equal minus 2. So these are the two initial values, one values where the value of the function is a positive, another value where the value of the function is negative. So according to the iterative scheme of a Regula Falsi method, x0 equal what? x0 equal a f of b minus b f of a divided by f of b minus f of a. Now from here we put the value for this one, x0 equal what? x0, this one is a 0 into f of b means minus 2, f of b into minus 2 minus b means 1, f of a 1 divided by f of b minus f of a. F of b is a minus 2 and f of a is a 1. So this one is a what? This one is a 1 by 3. This one equals 0.3333. x0 equal 0.333. Now we try to find out the value of the function at this point. So what is the value of a function at this point? F of x0. F of x0 is we put here in this case. So this one 0.333 ka whole cube minus 4 into 0.3333 plus 1. So what is the value for this one? We have already calculated the value for this one. The value for this one is a minus 0.2963. So at x0, what is the value of a function? Value of a function is a 0.2963. So in the next iteration, we interchange the values of x0 by a or b. So we replace the value of x0 by the b. Why? Because in a previous iteration at b the value of the function is negative. So what is the x1? x1 equal, we interchange the values b by the x0. So this become what? This become a f of x0 minus x0 f of a divided by f of x0 minus f of a. F of a. Now if we put the values of a, x0, f of x0, f of a here, then we find what? We find here, if we erase out this one, we find x1 equal a means 0, f of x0 means 0.333 minus x0 0.2963. 3, 3, 3, 3, f of a is a what? 1 divided by f of x0. F of x0 is a minus 0.2963 minus f of a means a 1. So, what is the value for x1? The value for x1, if we simplify this expression, the value for x1 is a what? 0.2525714. Now, in the next iteration, we repeat this procedure. Here we write down all the values means up to a fifth iteration. What is the values of different values means at each iteration, what are the values of x0, x1, x2, x3 approximate roots. So here a equals 0, v equal 1, then x0 equal 0.3343, x1 0.25714, x2 equals 0.25420, x3 equals 0.25410, x4 equals 0.25410. Now, if we closely observe the value of a function, you may see here this one is a negative, this one is also a negative, this one is also a negative, this one is also a negative, and this one is also a negative. Means here one is a fixed and that is a what? That is a positive. Negative end varies from minus 2 to minus 0.2963, minus 0.0115, minus 0.003, minus 0.401. Means a positive end is fixed and negative end varies. So, as the number of iteration proceeded, the value of the function approaches to the 0. As we know that as the value of the function approaches to the 0, then we able to approach here this sequence of means a root approaches to the actual solution. Now here, what is the difference between a and b? Means two initial points. Here a is a 0, b is a 1. Difference is a 1. If difference is a 1, in a 4 iteration means a first iteration, second iteration, third iteration, fourth iteration, here we able to find out what? We able to find out the root correct up to a 3 decimal places. In a 5th iteration, we able to find out a root correct up to a 4 decimal places. But what's happened in a bisection method? If the difference is a 1 means difference between a and b is a 1, then to find out a root correct up to 1 decimal places, there is a need of at least 4 iteration. But in a Regula Falsi method, what will happen? In a 4 iteration, the difference is already 1, means the difference between b and a is a 1 here also. But in case of a bisection method, n is greater than log b minus a minus log EPS divided by log 2. If you find the values of n for this value of a and b, the number of iteration required to find out the root correct up to 1 decimal places is what? 4. But in a Regula Falsi method, we able to find out up to a 4 iteration, we able to find out the root correct up to 3 decimal places. Even up to a number of iteration, if number of iteration is a 5, then we able to find out the root correct up to 4 decimal places. But in a bisection method, if we solve this equation by these initial values, by the bisection method, then to find out the root correct up to 1 decimal places needed at least 4 number of iteration, and for 2 decimal places need at least 7 number of iteration. But in a Regula Falsi method, if we consider same means initial values a and b, be able to find out in a 4 iteration, root is a character to a 3 decimal places, and up to a 5 iteration, root is a character to a 4 decimal places. What is the meaning of this one? Meaning of this one is a Regula Falsi method is a faster in comparison of a bisection method. Although the rate of a convergence of a bisection method and Regula Falsi method, both rate of a convergence of both methods is 1. Means the rate of a convergence of Regula Falsi method is also 1, but and rate of a convergence of a bisection method is a 1. But Regula Falsi method perform much better in terms of a number of iteration in comparison of a bisection method. So why this will happen? So why this is happening here means the number of iteration in a bisection method is larger in comparison of a Regula Falsi method. We will discuss when we discuss about rate of a convergence. Means if rate of a convergence of both method is a 1, then how Regula Falsi method is better than bisection method. So thank you for watching my lecture.